our next talk is entitled Perspectives on Scaling New Manufacturing Companies, and it'll be moderated by Professor David Mindell. Dr. David Mindell is a professor of aeronautics and astronautics at MIT and the Dibner Professor of the History of Engineering and Manufacturing, also at MIT. David spent more than 3 decades researching the different relationships between people and machines and innovating to improve them. He served as an MIT department head for 5 years and has led or contributed to more than 25 oceanographic expeditions and is an inventor on 34 different patents for autonomous aircraft, precision navigation, and human robotic collaboration. He's also the author of 6 books and an associate fellow of the American Institute of Aeronautics and Astronautics, a senior member of the IEEE. He is co-founder and executive chairman of Humatics Corporation and partner of Unless, which is revitalizing U.S. industry around decarbonization and equitable work. So thank you, Professor Mindell, for joining us today and for kicking off this afternoon's panel. Please give him a round of applause.
Thank you for that great introduction. It's a great pleasure to be here and to be moderating our final panel made up of folks who are, despite all the complicated global things we've been hearing about, creating companies, innovating, and facing a lot of these problems really very much on the ground, and including our last questioner. So first is Kyle Clark, who's the founder and CEO of Beta Technologies, an electric aircraft company in Vermont. And I'm not going to introduce the companies because I'm going to let the founders introduce the companies. And Dr. Shreya Dave, who's the founder and CEO of Via Separations and an MIT PhD, and a company that's sort of a flagship company of our local incubator, The Engine. And then David Lakatosh, we just saw, also an MIT grad from the Media Lab and head of product at Form Labs, which, as he mentioned, is a local and very MIT-connected 3D printer. So it's really exciting to hear from all these folks. And I'm going to start by just asking each of them to introduce their companies in 5 minutes or so, which they'll all, of course, do a much better job of that than I will. So maybe start with Kyle.
Sure. Assuming you all can hear me. Kyle Clark, founder, CEO of Beta Technologies. We're an electric aerospace company. We're actually just a couple hours north of here by driving and a couple minutes by flying in Vermont. Beta Technologies was actually my senior thesis project right down the road here at Harvard. And I had been pushing the business for about 15 years before I finally got some investment in it about 7 years ago. And we've grown from 1 person to about 700 people. And we've gotten about $1 billion of financing and just opened up a, what I believe is the largest net zero building east of the Mississippi as our new production facility for our aircraft in Vermont. And David's been a mentor and an advisor. First, I was just a student of his books, and then I got engaged with him, and he started helping me with thinking through some manufacturing and technology innovation challenges, and happy to be here and love to talk about what we're doing and the mistakes we're making.
Thank you. As an electrical engineer and a pilot and an aerospace professor, I'm a big fan of Beta Technologies. Everything I love, techie-wise. And
Hi, everyone. My name is Shreya Dave. I'm the CEO at Via Separations. Founded the company out of my PhD research at MIT. I was an undergrad mechanical engineer. Found myself to a material science lab where we were working on new filters for water filtration. Pivoted that into a focus on the chemicals industry. So we allow chemical manufacturers to ability to increase production through their existing assets, reduce their energy consumption, decarbonize their production facilities without having to pull it all up, rip it all out, and build a new facility. Focusing on about 20% of the industrial emissions that are here in separations. So happy to share mistakes we're making. Our big announcement, I guess, is that we've just completed construction on our first commercial plant, retrofitting a pulp mill, a paper mill in northern Alberta, outside of Calgary. And that is in commissioning and is happening and is like live updates. Got to check my phone, make sure everything's still going well at the end of this.
Great. Hi, my name is David. So Form Labs, we make 3D printers, came out of the Media Lab 2011, 12, out of Neil Gershenfeld's group. How many people here have taken How to Make Almost Anything? Anyone? Kind of.
Like, when
It's an
till like?
awesome class. If you have a chance, please apply. It's a really good class. Goal was always to create professional, affordable 3D printers, which means that when we started, if you wanted to use for work, a 3D printer, it cost upward of 100K if you really wanted to get the quality that you needed. We started on Kickstarter, raised $3 million from there. That was more than 10 years ago. Today, we're one of the largest professional 3D printing companies. So there were 130,000 printers in selective laser sintering and stereolithography. So GUI printers and powdery printers, all plastics and all for professionals. I guess just the topic of the day is Form 4. We just announced it about a week ago, and it's our latest and greatest awesome printer that if you are doing anything physical, it's a great compliment for your team. So hopefully you can check it out. And maybe one more thing for the manufacturing interested people. We've done, I feel like, almost everything. We started manufacturing our first printer in San Diego, second printer in Eastern Europe and Hungary, Central Europe, if any Central Europeans are there. I'm Hungarian, so I'm very sensitive to this. So, and then today we manufacture in China and Vietnam. So, seen a lot of mistakes along the way. So, happy to talk about any of that.
So maybe I'll start by asking Kyle. You mentioned you just opened a new factory in Burlington, Vermont, which is a state I spend a lot of time in, but not typically known as a manufacturing state, other than maybe Burton Snowboards, which I know you've drawn on quite extensively. Maybe you could talk a little bit about the facility and what it's been like, and why it makes sense to make airplanes in Vermont.
So over the short history of our business, we were constantly asked early in our developmental days, why aren't you in Silicon Valley? Why aren't you in Austin or Boston or wherever? Because that's where all the smart people were. And we were able to kind of break through that and say, well, that's not really the case. We've got a great quality of life in Vermont. We've got enough smart people. We only need a few hundred people, and there's 40,000 people in Burlington, which isn't a lot, but there's a lot. And a couple 100,000 people in the surrounding areas. So as we fought through that, we realized that we may flip that into a strategic advantage. And what we found in our industry of aerospace is more and more of those manufacturers had started in technology hubs and then moved their production facilities to Springfield, Ohio, or Georgia, or Raleigh, or outside of Raleigh in North Carolina, where the cost of labor was kind of in check with what was needed for the hundreds, if not thousands, of people that were necessary to hire. So we flipped that around a little bit and said, okay, what are the strategic advantages of being very close to the technologists? And maybe if we look at it from the other angle, what is the thing that could really screw us up as a business? It's messing up that progression from engineering, product development into manufacturing. And that required a very high touch point between the engineers and the technicians and the first article builds and the low rate initial production. And so we plugged all that together in a big campus and started to accelerate much faster than our peers, while they now have a strategic disadvantage in that their technology hubs are in San Francisco in many cases, and their manufacturing is happening elsewhere. So now we've put ourselves probably a year to a year and a half advanced to those folks because we were able to do a very, very fluid transition from engineering to manufacturing. And then as far as like getting skilled labor, our industry, aerospace, it requires a huge amount of training. It's a bidirectional investment, and it's a sticky labor kind of industry. And so we invested a lot in the tech schools. I went to the Essex Technical School before I came to school here down the street. And we invested in the tech schools, and we imported all of our leads, and they imported their kind of following folks from their manufacturing. So the labor market kind of solved itself, and we ended up in I would say, a really, really good position. And the last little thing I said is we got late last year, a $170 million injection from the Import-Export Bank of America on phenomenal terms. And that was in large part because we were creating jobs in a place that needed jobs to be created. So we kind of hit it on all fronts, and relative to our peers, I'd say that all of those things are resonating specifically the one of having engineers very close to the low rate initial production.
So Shreya, I've read that you have a big collaboration with International Paper, and maybe it's a fair assumption that that's the plant that you just opened.
Yep.
So maybe you could say a little bit about being a startup, what it's like to go through that chicken and egg credibility proven versus actually having the track record that a big company will bet on you, and how you navigated that, which is, of course, a critical scale-up component.
Yeah, absolutely. So we have a unique position where we are a manufacturing company in the sense that we make a product, a piece of hardware that we add to our customers are manufacturing companies as well. And the customers, whether in the pulp industry or in other industries, tend to be very large, very well established, and really, really good at what they do. And their number one and number two priorities are reliability and safety. And then third is, what are my margins? How am I making this commodity product just a little bit better than the competitor? And that is just pretty much the exact opposite of a startup. Not to say safety isn't important, it absolutely is, but we like to move fast. We take risks because we don't have assets that we're trying to protect. The Silicon Valley move fast and break things doesn't exist the same way in hardware as it does maybe in software, but it doesn't not exist either. And we pride ourselves on being super nimble and jumping, not having a lot of hoops to jump through. So there's a impedance mismatch there that we have to navigate. It's probably one of our strengths, but it is also something that continues to play a role in how we talk to customers. International Paper, for example, their biggest fear is that we won't be around in 10 years to service the equipment that we're putting on their facility. And so not only do we have to convince them that we have a business that's going to be around for 10 years, but we also have to convince them to pay enough for there to be a business, for there to be one in 10 years. And so we have a bit of a chicken and egg, like you said. For us, a really important part of it has been building credibility and recognizing that we truly are standing on the shoulder of giants of manufacturing. Has anyone here been to a paper mill by any chance? Yeah, okay, few people. They're very large and very much not high tech, right? They're very advanced technology, but it's not the semiconductor fabs that we were just looking at. You have equipment. I visited a mill where I was talking to the process engineer about their lines and their bottlenecks, and he said to me, well, our bottleneck used to be here, but we took this piece of equipment offline because it was built in 1919 and it was starting to get too expensive to maintain. And this was in 2017, and I was like, okay, 98 years old. All right, we got it. So just to put into perspective, both the scale of these commodity manufacturing products, and then also the way decisions are made, is a very different beast than the startup. So I don't know if I exactly answered your question, but just painting that picture a little bit.
Great. I sometimes tell my students, because I work in the subways in New York sometimes, and you should be so lucky that something you design is in service for 98 years and has to be replaced because it's getting to be a century old. What an accomplishment for the engineer who designed that thing.
Absolutely.
David, you mentioned a new product that you just came out with, and as Chief Product Officer, I'm sure you had a huge role in that. Can you talk a little bit about how much supply chain considerations were a concern or enable, or how you deal with that when you're introducing a new product in today's post-COVID world?
Yeah, and maybe let me start with a mistake and how I think a lot of companies start. The wrong way to approach supply chains is to think about it at the end. The right way is to do it in the beginning. And I know it sounds very trivial, but I think 100% of hardware companies mess this up. So if you're thinking about starting a company, definitely think about this, because as you mature, you think about the key components first. So yeah, every time we design a new product, we start with two fundamental questions. What do people want, and what can we make? And then you try to inch closer and closer for those two things to overlap. And the what can you make is very much rooted in supply chains. What are the new technologies that have been commoditized to the price point that it can overlap with what people actually want? 3D printing, and this is where the question that I asked one professor has really makes us thinking all the time, is there is a very rapid iteration cycle in 3D printing today. There is lots of exciting stuff happening in the fundamentally new technologies, costing hundreds of thousands of dollars or more. There's tons of innovation happening in the couple $100 category. If you go on Amazon and you Google 3D printers, you would not believe what are the things that you will find. And then there's a lot of things in between. So the more competition and the more segmentation there is, the more you need to be very critical about what is my price point and what do people want and what can I afford there. So that's the fundamental question always. So we do a lot of user interviews and research that is less sexy. It's not always, but it's very fundamental, very important to do in the beginning, so you understand what do people want, and then an incredible amount of engineering work that goes into what innovations are possible for us and how can we actually deliver it on a timeline that people will care, because the earth moves very quickly, and if you lose your cycle, then it's going to be irrelevant.
Great. Kyle, I wonder, similar question. You're an aerospace company, which is an industry with a very stressed supply chain right now. And some of Boeing's challenges have to do with that issue. Plus you have a whole lot of new entrants creating entirely new categories, buying motors, buying components, buying other things, who are in the same market that you're in. So how have you dealt with some of that? I know you make your own electric motors. That's kind of part of your core competence as a company. What is your assessment of the aerospace supply chain for a new entrant into aerospace manufacturing?
I mean, just the current state of the aerospace supply chain, there was this massive trend of airframers to push things off to supply, and not just push little things off, to have complete assemblies bespoke to their aircraft built outside of their control. And observing this happening, it yielded, I think, a strategy that I've communicated to our team over and over again, which is whenever we look at, we're going to make the airplane, the aircraft, and then as you break down the subs and the different elements, go only down as far as you find someone else uses the same thing. In the batteries, it actually goes all the way down to the cell. And so we buy the cells because somebody else uses those cells en masse. You go all the way down to the silicon carbide semiconductors. You go all the way down to, in some cases, the aluminum sheet. But nobody else is going to make the same frame bulkhead for that portion of an airframe as we are, because it's our bespoke design. So once you do that, you say, okay, you're allowed to buy something that somebody else can. And you're not allowed to buy something else unless it crosses a particular threshold. It has a piece of capital equipment that it's made on, say a 300-ton injection molding machine, that has an incredibly long lead time, or the amortization, or excuse me, the ROI on that particular machinery is going to be less than, we picked 7 years. Why? Because Harry Potter said it was the most magical number, and I checked with AI. So so if it has an ROI less than 7 years, then go buy the thing to make the stuff. And the reason that is like a make over buy at such a high level in our industry, or any medical equipment, to some extent space, definitely in aerospace, definitely in other regulated environments, pharmaceuticals, is that the regulatory oversight is so intense and pervasive that you have to produce all the artifacts of the manufacturing process. And it's a cluster to go to suppliers and compel them to get audited to produce in our case, for new and nascent technologies like electric motors, the statistically relevant data sets, so that the FAA says, oh yeah, I can agree that if you sample 8 out of 100 or 12 out of 100 or 100 out of 100, that's relevant to say the quality is top. So we have a high degree of buy over make. It has created the kind of fallout of this, and this is again the link to engineering to manufacturing, is a high rate of design for manufacturing. If you have to go through your purchasing and the chief engineer and the program manager of a supplier in order to elicit a change, it's slow. If you do it internally, it's quite fast, relatively speaking, in aerospace timescales. So that's kind of our strategy, and it's written down, it's cut and dry, and everybody follows it, and it makes for, there's a classic quote, the biggest impediment to innovation is indecision. It makes for decisive action by the supply chain team, which is part of innovation.
I remember you telling me a couple of years ago you could buy all the magnets you needed from China, but you couldn't get them with the documentation that you needed. That's to right. Let the FAA approve them.
Right, and there's like, and there was that chart earlier about batteries. I was looking at it thinking about magnets. It's like, I don't know what the number is. It's like in single-digit percentages of magnets that are made outside of China for rare earth magnets, and we have to go to a company in Germany to get magnets made to our specifications because they're able to produce the artifacts.
Shreya, what are some of the scaling challenges that you've been facing and expect to face for your next phase?
Yeah, so I have two thoughts here. Number one, our approach to manufacturing is quite the opposite, which I think is relevant to the different industries, right? We aren't nearly as regulated. We are, if anyone else can make the thing, let's someone else make the thing. We are not investing in manufacturing assets. We have not raised capital to build any manufacturing assets. Our building in Watertown is all lab and R&D. And that's because we developed a process. So we developed a chemistry and a process for manufacturing that was built entirely on an existing process. We said, okay, these are what the capabilities are. Therefore, this is what our chemistry needs to do. And we're going to rent time on your machine, and we're not going to buy the machine. We're not going to maintain it. We're not going to store it. We're not going to pay for electricity. We are going to rent time on your machine until such a point where we have 360 days of production. But right now, we're talking about 3 or 4 days of production to satisfy a year's worth of demand, which means that we need to be in every single pulp mill in North America at scale in order to have a year's worth of production. And that means that we can keep our costs pretty low and still make the margins that we need to. So it's really cool to hear about a different perspective.
Well, that wouldn't cross the ROI on the capital equipment.
Nope, it wouldn't.
threshold,
It
so
wouldn't
be
make
the
that
same
7
strategy,
magic
just a
years.
different
Exactly, magic number of years. But as far as scaling goes, we started with a technology that was coming out of my PhD, literally 1 square centimeter. We proved that the science could work, and it could work if you got all the sometimes enough to pass the defense. From there, we had to get it to work all the time. And then from there, we had to get it to work from 1 square centimeter to more than 2 football fields, which is what we have in production in operation right now. And then those get replaced every year. And so there's a pretty large order of magnitude. It's actually 100 million times. I know exactly how much it is. It's 100 million times the scale up, and that's on formulation, on the roll-to-roll coating, it's on the assembly. And so kind of 3 different components. And we work with 3 different contract manufacturers, none of whom are the only one we could work with. We have a preferred one, and they're all domestic. And so that we do for rapid iteration. Our roll-to-roll coating is in Massachusetts, so that we can actually go all the time. And every time we run a trial and run a test, we can go and do that, and do that for relatively inexpensive. So we went, from square centimeter, then a 10x, and then another 10x, then another 10x. And at some point, we actually had to make the 100x jump. And that's really scary, not only for us and our technologists and our engineers, but also for all of our investors and all the other people who say, oh, no, you never do more than 10x. But we're doing it. And I think that our lesson there is thinking really about where the complexity changes. What is different? Is it a surface area to volume ratio, or is it an engineering, or is it like you have to have the right amount of team coordination in order to get to that 100x? Each of those things is a very different beast and a different problem to solve. And so we kind of looked at it each time. And for a while, it did make sense to do 10x, but you can't get to 100 million times if you just do 10x's in 7 years.
Cool. So I'm cognizant of the time, and I want to leave time for questions. That's a much better way to end the day than the moderator talking. But looking out here, I see that there's at least 4 or 5 dozen of the MIT students who are about to found the manufacturing companies that are going to transform U.S. industry in the next 30 years. Lessons learned, mistakes made from your experience so far, starting with David, maybe.
One thing that just both of you made me think of that I think is also a lesson, we're somewhere in between, or not sure exactly. I can map out all the axes that our companies can be plotted around, but we talk about innovation tokens, and we remind ourselves that we have very finite amount of innovation tokens. So very common way to not be able to make it to the market or lose, especially as an MIT super smart person, is really trying to go too far in innovation without understanding where your market is and actually commercializing your product. We often get reminded, and in 3D printing, you can literally, the field is littered with dead bodies when it comes to failed companies that had an amazing technology that never seen a single customer. So translating that into maybe a little bit more practical, let's say that you got over that hurdle, we remind ourselves that every single time we need to go to the market, we have a certain number of innovation tokens. Normally, depending on the size of the project, it might be 20. And when we say, all right, we want to have a new printer and we want it to automatically dispense material. Seems like a reasonable thing to do, but there isn't anything off the shelf that we can use. That's something that we need to invest and invent, actually. And then we try to assign a number to it, let's say 6. And then we're only left with 14 innovation tokens. And it's really important that you remind yourself that every time you need to get to the market to learn more and to make your company not go bankrupt. So you need to, I think people think about innovation as like a prerequisite to start a company, which is true, but it's also probably the #1 reason why anybody fails. So I think doing the build or buy correctly, and there are different companies. In aerospace, it looks totally different, and you get much more innovation tokens. In 3D printing, it's a much more competitive and not commoditized yet, but on the way to being commoditized in some segments. So we get less innovation tokens, and we need to move faster. So I think learning how to know where you are is really important, and have that intelligence to like go out and talk to people and learn about your industry. I think that's like the #1 reason why I see companies fail, so don't make that mistake.
Kyle?
Yeah, I think my biggest learning is that and this was across our first 3 businesses, and this one is that, especially in manufacturing, the people are really, really important. And getting good people en masse. So in this facility we built, instead of being dark and dirty and kind of like dangerous, it is well lit, paid for a lot of glass. The people there, they get an organic free lunch every day. We have an on-site pharmacy and doctor and nurse, and everybody gets flying lessons for free. And our education policy is that people, if it has related to your job, the answer is yes, unless you're being stupid. And the company will cover it. So we have a lot of trust in people, and that's created a hell of a buzz around the company. And we pay less than a lot of companies. And net, like 3, 5, 8% of a particular person's compensation is in these types of benefits that show you care about people. Yet when you come and say to somebody, why do you work at Beta? They say, I got a great place to work. I get to go fly. I get lunch that's really good every day. My kid's sick. I get a pharmacy right here that writes me a prescription. I don't dick around with that stuff. And it's a different flavor. And that's solved the problem we thought we were going to have with a very small amount of investment.
Shreya?
That's really cool. Those were 2 very good examples. Investing in our people and thinking specifically about going to market. I think I'll share one example. So we exist in markets where there's a very, very high burden of proof, not because it's a regulatory market, but because customers, no person at any of our customers is going to get fired if they do it the same way they've been doing it for 100 years, even if it's inefficient, causes a lot of downtime, and is not aligned with their strategic decarbonization goals. However, if they do something new for the first time and it doesn't work, that doesn't look good. And so when we're looking at competition in the competitive landscape, our competition is just doing nothing. The industrial sector is more likely to do nothing than to make change that's drastic. That's a step change. And so for us, what was really important was piloting early, piloting before we felt we were ready. We went in, we thought we'd talk to the customer. We knew exactly what they wanted. They had 5 criteria that they wanted to see hit before they would kind of move on to the next phase. And we got there, and within 3 days, there was a 6th criteria. And we were like, well, it's a good thing we showed up with the 5 hitting, because now we have to focus on this one. We had 3 pilots scheduled for that year, went to the second customer. We're like, okay, well, we have this hypothesis around 6, but we're not going to say anything. And see, they had that 6th criteria too. And there was no amount of conversation, no number of PowerPoints, no numbers of virtual or in-person meetings that were going to get there until we showed up with a pilot system to actually have data coming out of. And so lesson there was we could have perfected those 5 criteria for another 5 years, 10 years, and it wouldn't have mattered. We wouldn't have had a product that could have gone to market because we didn't know about that 6th one.
Okay, questions?
Privately held right now.
We're private.
Yeah, I figured. Okay. So, and that's the direction my question is going to go. So first, on the labor thing, brilliant discovery. Did the same thing. What a lot of, if we've got the future of manufacturing here, just remember the way to get the really smart people from inside the 95 belt is to remind them that if they work outside the 95 belt, they can commute for 30 minutes for the same money that they would have to commute for 4 hours with, right? So I think that it's the lifestyle thing that you were pushing for your employees and how you care for your employees that draws that talent in. I really do. But that's also the conundrum, right? Your manufacturing model is, I mean, if you look at it historically, you're doing what Henry Ford did, right? Bring in raw materials, build everything. It reduces the risk on your supply chain. It's an awesome approach to it. And the way you're treating your employees with facilities and with all the extra benefits, also really great. But you're going to have a very, very successful company. And one of these days, somebody's going to push you into an IPO, and then you're going to be a publicly traded company. And I want to know how you're going to manage to fight the pressure to reduce costs, to get rid of those fringe benefits, to outsource a lot of that stuff so that you can increase production and increase your margin and answer all those pressures from the investors while maintaining the phenomenal model that you've built as a private company?
It's a good question, near and dear to my heart. It's not complicated though. I apply the regrettistus game theory on every decision I make, including going public, of which we've had numerous offers to. And what is the thing you'd most regret in 3 years, 5 years, 10 years, whatever it is? Number one is running out of money. Number two is losing control of the ship. And number three is actually, for me, having disproportionate amount of dilution or the actual cash out of whatever. I have no interest in exiting this company. I have no interest in losing control of the company. And I certainly want to see it delivered in that order, right? So that's what I applied every time we got offered to be a public company. And the answer was no at every juncture so far. We've got the capital we needed, maintain 100% control of the company myself. And I'll tell you that I'm way less interested in doing something that is not meaningful, mission-driven, and fun than making a boatload of dough. So that makes those decisions really easy. In fact, we've had numerous investors come to me and say, I'll make you a billionaire right now. You need to A, stop being the chief test pilot. You need to change all these different parameters within your company. I'm like, okay, go find another stock to invest in. There's plenty out there. And even back to my second company, the reason I left when the private equity company bought it is they said, hey, you can't fly yourself anymore. I said, oh, really? Well, I'm gone. And said, we don't get each other, do we? I'm not here to make money doing this. This is something I care about. The ironic thing is that doing those types of things draws investors who share that type of philosophy with you and customers. One of our biggest customers, United Therapeutics, has very similar corporate policies. This is a wild story and I won't put a name on it. I was asked the other night to come over to the hangar. And I came over to the hangar and there's a 1941 Stearman biplane. We didn't even talk about this. And with it is a letter. And it says, Kyle, I was so inspired when I saw your company. Consider this a gift and an affirmation for what you do. And when we're ready, we want to buy airplanes from you guys. And he gave me his father's Stearman biplane, because what I do with every intern, we have 80 interns a summer. I fly with every single intern, do aerobatics with them, and make sure they get to experience the love of flying. So that question, I don't mean to resonate with it, but screw them if they don't want us to do that. If they walk in and say that control of the company is really important to me, control over the board and control 100% of the voting shares is important so that we don't end up in that situation. And I prioritize that over valuation, even though we have a multi-billion-dollar valuation. That's awesome. I think so too.
Thank you. Question for Kyle. And first, I can attest to the benefits, and the granola and snacks and your facility is fantastic. The second one is you talked about, it's a little bit more specific about your manufacturing facility. You talked that it is net zero building. As an electric aviation company, there's kind of the moral commitment and probably on brand. But when you were, when you guys thinking about building that facility, was there any consideration or complications, financial ROIs, or things that it might not could allow you to do versus not allow you to do to have a net zero manufacturing facility in that area?
Well, so I applied the same thinking as I was talking about on the supply chain. It turns out it's really interesting. When we make really big buildings and you want to make them net zero, the return of investment is compressed drastically. We put in about 300 geothermal wells for all the heating and cooling because you have to have about 3-degree tolerance in a manufacturing building building precision airplanes. And it was about a $13 million investment to make it net zero in heating and cooling, a little bit more for the solar. And the solar, of course, powers the geothermal wells. And it ends up, like I said, a 3.5-year ROI because the drilling rigs for the wells, a singular controller, a huge, actually off of a cruise ship heat exchanger, made the cost of that relatively small compared to the scale of the building. So financially it worked. It's a recruiting tool. And the other thing is our customers actually appreciate it. We have a full-time auditor who exclusively looks at the net and sustainability impact of our total operation, not just whether you're putting jet fuel into a plane or electrons, but also how we build it, how we recycle end of life, beginning of life, and that becomes important to our customers. So it was a win all around, and as soon as you look at it with a wide aperture, it was immediately clear to make this building net zero.
Okay, we're out of time. Join me in thanking the panel and thanking everybody for a great day.